Okay, everyone. Now let's do the last section of the review worksheet. Let's work on number 15. Number 15, it says graph the y equals x squared minus 2x minus 3. And we want to identify the vertex, axis of symmetry, min or max value, the x-intercept, and the y-intercept. Okay, so those are the stuff we have to get as well as graph this function. So let's try number 15. Number 15. So what we want is we want to graph y is equal to x squared minus 2x minus 3. And we want to get all the other stuff the question's asking as well. The vertex, the symmetry, maximum value, y-intercept, and x-intercept. So first thing we got to do is to graph it. How do we do it? Well, we need the vertex. That way we can graph it and knock out one of the questions. So vertex. This is not in vertex form, so we cannot tell what the vertex is just by looking at this equation. So how do we get the vertex for this quadratic equation? Well, we know the x portion of the vertex. I'm going to just write the x portion. The x coordinate of the vertex, we know we can get that by using negative b over 2a. So let's do that. What is b and a? Well, we know this is the a value, b value, and the c value. So negative b over 2a, we know that is equal to negative 2 all over 2 times 1. And negative 2 is positive 2 over 2. And the x portion of the vertex is 1. The x coordinate of the vertex is 1. How do we get the y coordinate? Well, that is simply just plug in 1 into x and solve for y. So let's do that. We have 1 squared minus 2 times 1 minus 3. 1 squared is 1, minus 2 is negative 1, minus 3, negative 4. So we already got one piece of the information needed. Vertex is equal to 1, negative 4. Now we got the vertex. Okay? Now before we would graph it by set up a table with the vertex and pick a point to the left of it, pick a point to the right of it, which is great. But now we have a new power in our hand, and that is finding the x-intercept. With that, we get a much more accurate graph. And by finding the x-intercept, we also knock off another question that they're asking, which is to find the x-intercept. So let's do that. Do you guys remember how to find the x-intercept? Geometrically speaking, what are we talking about? We're talking about where x-intercept, where does a graph cross the x-axis? Where does it cross the x-axis at? And how do we find that out? When we talked about earlier, to find that out, you will set the y to 0. Because for each of these points on the x-axis, the y value of it has to be 0, or else it cannot cross the x-axis. The y value of it has to be 0. So let's set this equation to 0. So we have x squared minus 2x minus 3, and we're going to set it to 0. And our job is to solve for x. What will be the value of x that makes this equation true? Well, if we look at it, we can factor this. This can be turned into x minus 3, x plus 1. This can be factored into that, and that is equal to 0. So to solve for x, we simply have to set each of these portions, each of these components to 0. So x minus 3 equals 0, x plus 1 equals 0. We get x is equal to 3, x is equal to negative 1. So these are the two values where it crosses the x-axis. So now we have more information. Now we can actually make a better graph. And let's graph that. So let's graph this thing. So this is my x, and this is my y. Okay? So what did we say was? We said the vertex here, if we look at it, the vertex is at 1, -4. So 1, 2, 3, 4, -4. That is my vertex right there. 1, -4. Now before we would pick a point left of it and right of it and we get our little parabola. Now we can get a much accurate parabola because now we know where it crosses the x-axis. So where does it cross the x-axis at? It crosses the x-axis at x equals 3 and x equals -1. So x equals 3 and x equals -1. Now notice we have a much better version of our graph. Okay, we have a much better version of how to graph it. So now the question asks, so we already got the x-intercept. We have the vertex. Let's find the y-intercept. How do we find the y-intercept again? Well, we know the x-intercept is when you set the y value to 0 because that's the only way it can cross the x value. The y-intercept is where does it cross the y value? This y point. Where does it cross that at? And to find that, remember the x value has to be 0. So what we can do is we can set the x to 0 and solve for y. So let's do that. Y is equal to 0 squared minus 2 times 0 minus 3. 0 squared is 0 minus 0 minus 3 is -3. So where it crosses the y-intercept is at -3. So the coordinate of it is 0, -3. And that is my y-intercept. This is my vertex. I'll just box everything we need. So we found the vertex, we found the x-intercept, and now we found the y-intercept. So in fact, we can actually make the graph even better. So let's take a look. Let's actually make the graph a little bit better. We have more information now. This is my x value, x line, my y. Okay? So we know the vertex is at 1, -4. 1, -4. We know it crosses the x-axis or the x-intercept at 3, -1. 3, -1. And we also know that the y-intercept is at 0, -3. 0, -3. Bam. So notice how many points? We have a lot more points now. So we're able to draw a much more accurate graph that's supposed to go through than before. Okay? So we got the vertex, we got the x-intercept, the x-intercept, we got the y-intercept. We graphed it pretty much. What else do we need? Well, we need to know the axis of symmetry. So the axis of symmetry, remember, is what is that line that cuts this parabola in half where they're mirror images of each other? Well, notice that it's just the x component of the vertex, which is x equals 1. So if you graph x equals 1, that is this line. Boom. And that cuts this parabola in half. So that is my axis of symmetry. And now the other question is, what is the min or max value? Well, the min value we already know. It's 1, -4. The min value. This point, -4. The y value is -4. Max value, well, we have none because these graphs go out infinitely up. So we have a min value. Okay? So the min value is -4. So now we have, so that is number 15. And now let's see. And now I'll do number 16 with you guys. Number 16. 2 times, okay, parentheses, x minus 3 squared equals 36. If the question asks to solve, what does solve mean again? Means what is the x value? What is the x value that makes this equation true? So let's do that. Number 16. We have 2x minus 3 squared equals 36. Now, how do we do this again? There's a few ways you can do this. There are a few ways, but the one I'm going to do is I'm just going to get x by itself by doing some algebra to this. Okay, so let's get x by itself. We need to get rid of the 2, we need to get rid of the square, we have to get rid of this -3 to get x by itself. So what's the first thing we want to get rid of? We have to get rid of the 2 first, okay? Because we can't square root here, because that way we have to square root 2 as well, and it gets more complicated. So let's just get rid of the 2. Divide by 2, divide by 2. We have x minus 3 squared equals 18. And now let's get rid of this square here. So to get rid of that, we have to do square root. So let's take square root of both sides. Okay? We take square root of both sides, we get x minus 3 is equal to square root of 18. Plus or minus there. Plus or minus square root of 18. And let's simplify that. Let's simplify the square root of 18. This you can think of as divided into square root of 2 and square root of 9, which will give you 3 square root of 2. So this can be rewritten as x minus 3 equals plus or minus 3 square root of 2. And now let's add 3 on both sides. X equals 3 square root of 2 plus 3. And that would be my value for x. That's number 16. And then we're going to do number 19. Number 19. So number 19 says x squared minus 6x plus 11 equals 0. And once again, we want to solve for x. Number 19. We have x squared minus 6x plus 11 will set to 0. First thing I see when I see this is, can I factor this into 2 factors? Well, let's think. 11. What goes into 11? Nothing much. It's a prime number, so we know only 1 in the 11 goes into it. And 1 plus 11, 1 minus 11, any of those combinations will not yield me a -6 in any way. So we know factoring is not going to work. And if factoring is not going to work, what else? What's our next method? Remember we did this in class earlier. We can use the quadratic formula. Once factoring doesn't work, we could plug in the quadratic formula, okay? So let's do that. What is our quadratic formula again? It is negative b plus or minus square root of b squared minus 4ac, and the whole thing is over 2a. And what is this? My a value, b value, c value. So my a value is 1, my b value is negative 6, my c value is 11. So let's plug it in. X equals negative b. So negative of negative 6 is positive 6, plus or minus square root b squared. Negative 6 squared is 36, minus 4. What is a value? 1. C value? 11. The whole thing's over 2 times 1. Yeah, just simply plug in a, b, and c from our equation. So let's simplify this. Let's simplify that. 6 plus or minus square root. Let's simplify the inside. We have negative 4 times 1 times 11, negative 44. Negative 44 plus 36, we get negative 8. Boom, negative 8. All over 2. Okay? Now, notice that's negative 8. So we know that it's going to involve some kind of imaginary numbers for the solution. Okay, so let's simplify that. Remember how we simplify it? So let's just take the square root of negative 8 and let's simplify that right here. I'm just going to do a little box and we're going to simplify inside here. Square root of negative 8. How do we simplify that? Well, that can be rewritten as negative 1 times 8. Right? Okay, so then this then can be written as negative 1 times 8. Now we know this is going to be I. So let's simplify square root of 8. Square root of 8 can be written as square root of 2, square root of 4. And this is simply 2. So negative 8, this portion can be written as 2, square root of 2. Because square root of 4 is 2, and then multiplied by square root of 2. And don't forget the I on the outside. So this whole thing can be written as 2i square root of 2. Okay, so 2 times I times square root of 2 will just give me 2 times I times square root of 2. So now I'm going to come over here and I'm going to rewrite this portion as 6 plus or minus 2i square root of 2 all over 2. Good, we're very close to being done. Now, we have to simplify. Notice there's a 6, a 2, and a 2. So they all have a factor of 2 in common. So let's take out a 2 from each of the factors. Divide everything by 2. If we do that, we get 3 plus or minus, because 6 divided by 2 is 3. 2 divided by 2 is 1. So I'm just going to put I square root of 2. And then 2 divided by 2 is 1. So my full answer here will simply be x is equal to 3 plus or minus I square root of 2. Okay, so that is number 19. And then the last problem that I'll work on with you guys is number 22. How many real solutions does this have? Okay, there's a couple ways you could do this. There's a couple ways. So we'll do it using 2 different methods. So let's try that. You could either do it graphically or you can do it using the quadratic formula. So let's just write that down. Number 22. The question asks, we have x squared minus 2x plus 3 equals 0. And our job is to find out how many real solutions does this thing have. Notice the question is not asking how many solutions, but how many real solutions. And what's the difference between real solutions and solutions? Well, geometrically speaking, graphically speaking, a real solution is a solution that actually crosses the x-axis. And that is different because a solution can have imaginary numbers which never crosses the x-axis. So they are asking you how many real solutions. How many solutions actually physically crosses the x-axis? So to do that, let's do it graphically, and then I'll do it using the quadratic formula. So the first thing we want to do is, let's find out what the vertex is, and let's see if the parabola actually goes through the x-axis. So how do we find the vertex of this? Remember, the vertex, the x value of the vertex, which I'm just going to write x of the vertex, the x component of the vertex is simply negative b over 2a. Negative b, in this case, negative of negative 2 over 2 times 1, 2a, because this is my a, my b, and my c value. So negative of negative 2 over 2, we said it was 1. The whole thing is 1. And if we plug 1 into there to get the y values, the y vertex is simply 1 squared minus 2 times 1 plus 3. 1 minus 2, negative 1. Negative 1 plus 3 is 2. So we know that the graph has a vertex of, let's plug in 1 and then 2. We have a vertex right here. Now, from this we can already tell. Now the question is the parabola going to be going up or going down? If it's going down, then it will have a solution. It will have to cross the x-axis. But if it's going up, it'll never cross the x-axis. Well, we don't even have to pick points. We can just look at from this equation. The a value in front is not negative. If it's not negative, we know it's going to be pointing up somehow. We don't care how it's pointing up. We just know that's going to go up. If it's going up, it'll never cross the x-axis. But if you're not certain, you can always make a table. Pick any 2 points that you like. So we have the vertex 1 and 2. You could pick 0 and you could pick 2 and graph 3 points to see if it's actually pointing up. But we can just tell from the equation itself that since the a value is not negative, this graph has to be pointing up. And if it's pointing up, we know it won't cross it. So this is one way you could figure it out is number 22, how many real solutions? Just right here, you could put 0. There is no real solutions. There are solutions to this answer, but there's no real solutions. There's no solution that actually cross the x-axis. So the other way to do this is by using the quadratic formula. So let's try that. Let's use the quadratic formula. X squared minus 2x plus 3 equals 0. So once we get to a certain step in the quadratic formula, if we start having imaginary numbers, we know that there's no real solution. So A, B, C, okay? We haven't got to indiscriminates yet, so we're going to just do the whole quadratic formula as is and see how it works, okay? So what's the quadratic formula say again? Negative b plus or minus square root of b squared minus 4ac all over 2 times a. So let's take a look. Negative b. What is the negative of negative 2? That's just positive. Plus or minus square root of b squared, which is 2 squared, negative 2 squared, minus 4 a, which is 1, c, which is 3, all over 2 times 1. Now let's simplify this a little bit. So I'm going to rewrite this as 2 plus or minus. Let's simplify the inside. What is negative 4 times 3? Negative 4 times 3 is negative 12. Negative 12 plus negative 2 squared, which is 4. So negative 12 plus 4, negative 8. All over 2. Now notice that it's negative 8. So right there we can tell there's going to be an imaginary number. If it's going to be an imaginary number, we know that there are no solutions, no real solutions for this equation. Okay, for quadratic equation, if we get to imaginary numbers, we know that there's no real solutions to this. So we can stop right here. We can see that it's negative 8. We know that if we try to simplify this, I is going to pop out. There's going to be I somewhere, which is imaginary. So we can stop right here saying there are no real solutions to this equation. Okay, so I hope this helps everyone. Okay.